What if the biggest mystery of the 19th century isn't who built the empires, but how they built anything at all? Picture this. It's 1886. No highways, no diesel trucks, no electric cranes, no modern supply chains. And yet somehow, in the middle of what historians describe as a rugged, developing frontier city, millions of perfectly uniform bricks appear. Not hundreds, not thousands, millions. Enough to raise palaces, universities, hotels, government buildings, structures so precise and decorative that even today contractors would pause before quoting the job. Now here's the uncomfortable question nobody wants you to ask. Where did 3 million bricks come from without factories as we understand them, without reliable rail infrastructure, without paved logistics networks, and without a modern industrial ecosystem to support that scale? This isn't about denying history, it's about doing math. Because when you run the numbers, the romantic image of dusty workers heroically stacking bricks with wooden shovels starts to wobble. Let's slow this down. To fire a single brick, you need clay. That clay must be mined, transported, filtered, mixed, shaped, dried, and then fired at temperatures that reach around 1800 degrees Fahrenheit. That temperature isn't casual. It requires sustained, controlled heat for long periods. Multiply that process by 3 million. 3 million bricks for just one major structure. Now calculate fuel. Historical records from similar projects show massive wood consumption, entire forests worth. We're talking the equivalent of hundreds of rail cars filled with dry timber just to fire enough brick for one large institutional building. And here's where the puzzle tightens. If rail transport was limited or still expanding, how did hundreds of rail cars of wood arrive consistently? If roads turned into mud during seasonal rains, how were thousands of wagon trips executed without grinding the entire operation to a halt? If each wagon could carry only a few hundred kilograms, how many trips would be required to move clay alone? Run the math, not emotionally, logistically. Even if you had 200 wagons operating daily, how many months would it take to move enough raw material? And that's before factoring in fuel, and before factoring in food for workers, and before factoring in equipment maintenance. History textbooks show men in suspenders and caps smiling beside nearly finished buildings. They look proud, respectable, clean, almost staged. But where are the images of foundation trenches large enough to swallow a modern house? Where are the photographs of pulley systems lifting multi-ton stone blocks? Where are the mud-filled supply yards stacked with raw clay? Instead, we see finishing touches, paintbrushes, final plastering, decorative trim. It's as if we're shown the ribbon-cutting ceremony, but not the engineering marathon that made it possible. Now let's talk about the factories themselves. Brick production at industrial scale isn't a backyard operation. It requires mechanical mixers, extrusion systems, molds, kilns, temperature monitoring, and precision control. Gears, shafts, bearings, metal components, replacement parts, skilled machinists. When one gear fails in a production chain, everything stops. Historical accounts from construction committees of the time mention exactly that. A single cast iron gear shatters and production halts for months. Replacement parts must be ordered from abroad. From abroad in the 19th century, delivery time measured not in days, but in seasons. So here's the next uncomfortable question. If one factory out of dozens could shut down for months due to a broken component, how did simultaneous mega-projects continue without interruption? How did dozens of ornate buildings rise at once? Because they weren't simple rectangles. Look closely at surviving 19th century brick architecture. Not just walls, profiles, cornices, rounded elements, custom corner bricks, decorative inserts, arched frames. Some facades use 30 to 40 unique brick shapes. Each one requires a separate mold. Each mold requires precise metal casting. Each cast requires a drawing accurate down to the millimeter. This isn't intuitive craftsmanship passed from father to son. This is systematized industrial design. And yet, where are the documented schools training masons to read complex architectural blueprints? Where are the preserved textbooks detailing multi-profile brick sequencing? Where are the standardized technical manuals? We're told it was tradition, skill, experience. But precision geometry does not emerge from intuition alone. It emerges from systems. Now imagine the construction site logistics. Different brick types arrive in batches. They must be sorted, organized, stored without damage, protected from moisture before firing and after firing. The mason must know exactly which brick belongs at which elevation and orientation. A misplacement at level 1 disrupts symmetry at level 3. If you've ever built even a backyard patio, you know how quickly small measurement errors compound. Now scale that to 5-story facades with decorative curvature. Something doesn't align. And then there's the transition. Walk through cities with surviving 19th century masonry. Massive brick mansions stand beside simple wooden structures, log cabins, timber houses, quick builds, minimal ornamentation. Wood is easier, faster, less durable. Anyone with basic carpentry skill can assemble a timber frame. No kilns, no precision molds, no months-long drying cycles. So why would a city capable of high-precision industrial brick production suddenly pivot to wood as the dominant material? The easy answer is economics. The rich built with brick, the poor built with wood. But examine specific cases and the narrative blurs. In multiple locations, wooden houses mirror the exact perimeter of older brick foundations beneath them, not similar, exact, within inches, sometimes even following unusual curves including rounded corners that make no structural sense for a wooden log build. Why replicate an expensive curved masonry footprint for a simple timber structure? You wouldn't, unless the foundation was already there. Rounded brick corners are labor-intensive. They require shaping dozens of bricks to form smooth arcs. That's architectural luxury. Why bury that effort beneath a modest wooden house? Unless the wooden house came later. Now imagine a different sequence. A fully developed brick city exists. Industrial capability, organized production, architectural planning. Then something disrupts it. Flooding, mud flow, soil displacement, catastrophe of some kind. Lower floors buried, drainage systems compromised, water tables altered. Buildings remain, but partially submerged. The easiest survival strategy isn't to excavate entire districts, it's to adapt. Convert second floors into first floors. Board up lower windows. Add external staircases. Install shutters not to stop burglars, but to block environmental conditions. Dust storms, wind-driven debris, persistent climate shifts. External shutters that lock from the outside make little sense for theft prevention. They make more sense as rapid sealing systems during environmental events. Now layer in another detail. Old photographs often show strangely empty streets, massive stone avenues, monumental buildings, barely any people. The official explanation is long exposure photography. Moving objects blur and vanish. Fair enough. But why are there no blurred crowds? Why no partial smears indicating busy streets? Why so many images that look like a city waiting, not a city building? It's as if documentation begins after something already existed. And then comes memory. Architectural details resembling memorial forms. Urn-like structures atop rooftops, decorative bowls with internal shafts lined in metal. Officially labeled eclectic decor, pure ornament. But if purely decorative, why internal metal lining? Why ventilation shafts? Why engineering effort inside what could have been a simple plaster mold? Across cultures, flame bowls symbolize remembrance, eternal flame memorials. Grief cast into architecture. If a catastrophic event preceded reconstruction, memorial forms make sense. If later authorities sought narrative control, removing overt symbols of past trauma also makes sense. After political revolutions, regimes rewrite textbooks. That's not controversial, it's historical pattern. New power stabilizes itself by defining the past. The question isn't whether history is curated. The question is whether scale and logistics were simplified for the sake of a cleaner narrative. Let's return to the bricks. 3 million bricks require not just clay and fuel, but consistent quality control, uniform dimensions, controlled shrinkage rates during drying, proper kiln stacking, temperature monitoring without digital sensors. That demands experience at scale. If such industrial ecosystems existed robustly, why do they appear to flicker out so quickly in certain regions? Why do we see a drop in masonry complexity within a generation? Technological regression isn't impossible. It has happened before. The fall of Rome led to centuries of architectural simplification in parts of Europe. Infrastructure can be lost when systems collapse. So instead of asking whether history is fake, maybe we should ask a more grounded question. Was there a period of disruption in the 19th century that forced adaptation and simplified rebuilding methods? Because the physical evidence in some cities suggests layering. Buried arches below ground level, windows beneath modern street height, foundations deeper than expected. Either builders deliberately sank entire first floors below grade, or ground levels shifted. When you stand beside one of these structures and see an arched brick opening partially underground, it challenges the neat story of linear progress. And this is where math meets memory. Historians are not villains, but institutions prefer coherent narratives, smooth transitions, heroic labor, industrial triumph. Complex disruptions complicate that story. If cities were partially inherited rather than entirely constructed from scratch, the psychological impact is enormous. It reframes identity. It suggests continuity interrupted, not simple growth. And people are uncomfortable with interrupted narratives. So let's be clear. The question isn't whether 19th century builders were capable. They absolutely were. The question is scale, timing, and continuity. Did the documented logistics truly match the physical output? Did the recorded workforce numbers align with production capacity? Did fuel supply chains sustain kiln output without interruption? Or were we shown selective documentation, the finish, the celebration, the staged pride, while the deeper logistical backbone remains fuzzy? Because when one broken gear could halt production for months, simultaneous mega-projects strain plausibility unless redundancy was massive. And if redundancy was massive, where is the infrastructure record supporting it? Forests logged at extraordinary rates leave ecological footprints. Massive clay extraction leaves visible quarries. Large-scale kiln fields leave remains. Some exist, but in certain locations, scale appears disproportionate to documented industry. It's like finding a skyscraper in a town that supposedly had no steel mill. None of this proves a hidden civilization. That leap would be reckless. But it does justify scrutiny. It justifies asking why so many ornate brick structures appear in concentrated bursts, followed by architectural simplification. It justifies asking why some buildings seem partially buried relative to modern street level. It justifies asking why the imagery of construction focuses on the final brushstroke instead of the foundational chaos. Because math is neutral. 3 million bricks either require colossal coordination or they were inherited. And if even a fraction were inherited, if rebuilding incorporated existing frameworks, the narrative changes from built from scratch to adapted from what was already there. That shift alone would transform how we view resilience, catastrophe, and the fragility of technological ecosystems. The 19th century wasn't primitive, it was inventive, capable. But invention doesn't immunize against disruption. And maybe the real story isn't that historians lied. Maybe it's that we stopped asking uncomfortable logistical questions. Maybe the bricks aren't mysterious. Maybe what's mysterious is the silence around the math. And we've only just begun calculating. Let's go deeper. Because the brick count is only the surface-level puzzle. The real tension begins when you examine engineering continuity. Imagine you are responsible for building a massive university in the late 1800s. Not a farmhouse, not a barn, a multi-story institutional structure with symmetrical facades, arched windows, ornamental brick profiles, and load-bearing masonry thick enough to last centuries. You don't just need bricks, you need precision. Each brick shrinks slightly during firing. If moisture content is inconsistent, shrinkage rates vary. If kiln temperature fluctuates, strength changes. If strength changes, load distribution changes. That affects structural integrity. Now multiply that risk across 3 million units. Modern brick plants rely on thermometers, gauges, calibrated systems, standardized molds, controlled airflow. In the 19th century, temperature was often judged by flame color and experience. Skilled? Yes, but scaling that consistently across dozens of simultaneous projects requires stable infrastructure. And stable infrastructure requires stability in society. So here's another question. What happens if that stability is interrupted? Let's examine something physical and undeniable: street levels. In multiple old cities across the world, you can find buildings where windows sit below current ground level. Not basement windows, full arched windows with decorative framing, now partially buried. You can argue urban resurfacing, roads get raised over time, that's true. Cities repave, add utilities, layer asphalt. But asphalt layering adds inches, maybe a foot or two over many decades. It does not typically bury entire window arches that were clearly designed for above-ground visibility. So when you see arched brick windows halfway underground, you have to ask, was the street raised gradually, or did a significant sediment event alter grade levels more dramatically? Now imagine an urban area originally designed with proper drainage. Brick buildings rely on foundations set below frost line but above water table. Engineers understood groundwater behavior. If you build in a swamp, you drive piles, reinforce base layers, create drainage systems. But what if a previously dry district becomes marshy? In some historic districts labeled as swamp areas, heavy brick buildings stand where modern engineers would hesitate to build without deep foundation systems. Yet these structures have stood for over a century. That suggests that when they were constructed, soil conditions were different. So what changed? If a large sediment deposit, clay, silt, debris, blanketed parts of a city, it could alter hydrology, block natural drainage, trap groundwater, raise effective water tables. What was once stable becomes soggy. Lower floors flood, basements fill. Owners abandon ground levels and adapt upper floors. You don't need a mythical apocalypse to explain this. Flood cycles, river shifts, massive regional storms, even glacial melt patterns could alter local environments dramatically within decades. But here's the catch. If such events occurred at disruptive scale, why aren't they central in mainstream narratives of certain cities? Why do we see heroic industrial growth stories instead of recovery from catastrophe stories? Because catastrophe complicates pride. It's cleaner to say, we built this. It's harder to say, we inherited ruins and adapted. Now let's talk about photography again. Long exposure does blur motion, that's real. Early cameras required subjects to remain still, but construction sites are chaotic. Even blurred movement leaves traces, ghost-like streaks, partial forms. Yet many archival construction photos show something else. Nearly completed structures with neatly dressed men holding tools as if pausing mid-action. Look at their clothing. Dark jackets, pressed trousers, polished shoes, hats. They appear prepared for portraiture, not labor. Anyone who has worked construction knows what mortar does to fabric. It stains permanently. Lime burns skin. Brick dust coats everything. These men look like they dressed up for documentation. Now consider this possibility. What if some construction photos were not documentation of building from scratch, but documentation of renovation or finishing after adaptation? If you inherit a partially intact structure, your job isn't to lift every stone, it's to repair, plaster, repaint, restore symmetry. The most photogenic moment isn't excavation chaos, it's the clean finish. That would explain why we see so many images of final touches and so few of foundational beginnings. Again, this is not proof of deception, it's a question of emphasis. Let's pivot to industrial fragility. Historical records mention factories halting production because a single cast iron gear shattered. Replacement parts had to be ordered from abroad. Delivery times stretched months. Think about that. A city allegedly operating dozens of brick factories relies on imported precision components. One mechanical failure can stall output long enough to delay major projects. If supply chains were that fragile, simultaneous mega construction booms become more difficult to reconcile. Unless production wasn't as continuous as we assume. Unless bursts of activity were interspersed with long pauses. Or unless some of the structural core predated the finishing documentation we associate with those years. Now consider workforce specialization. Ornamental masonry requires more than brute strength. It requires blueprint literacy, geometric understanding, tolerance awareness, the ability to follow multi-layered elevation plans. Where were these specialists trained at scale? We have evidence of architects, yes, but large networks of technically trained masons capable of executing 30 to 40 unique brick profiles on a single facade? That implies institutional education or apprenticeship networks robust enough to maintain consistency across projects. And yet, in some regions, that institutional continuity seems faint. Then, abruptly, complexity drops. Simpler builds, more wood, less ornament. When civilizations experience resource strain, they simplify. After the Bronze Age collapse, societies reverted to less complex metallurgy for generations. After Rome fell, monumental stone architecture declined in many areas. Technological regression is historically documented. So perhaps the real story isn't hidden super technology. Perhaps it's partial loss. Imagine a city with functioning industrial brickworks, skilled craftsmen, supply chains, then a series of disruptions, economic, environmental, political, fracture that system. Factories break down. Replacement parts are scarce. Fuel becomes harder to secure. Clay quarries flood or collapse. Skilled labor disperses. Rebuilding continues, but simpler. Wood becomes practical, faster, less infrastructure dependent. Decorative excess fades because survival efficiency dominates. That trajectory feels historically plausible, but if that's the case, why do textbooks often portray smooth, confident expansion instead of fragile oscillation? Because progress narratives inspire, fragility narratives unsettle. Now let's examine symbolic erasure. After revolutions, regimes routinely remove prior symbols. Statues fall, plaques disappear, street names change. That's universal human behavior. If certain architectural elements symbolized mourning or prior events inconsistent with the new ideological story, removal would be predictable. What remains then is stripped architecture, structure without context. Later generations see decorative bowls, wreath designs, unusual rooftop forms, and label them eclectic style because functional explanation has faded. Over time, memory condenses into aesthetic categories. Here's a subtle psychological layer. When people believe they built everything themselves, they feel ownership and continuity. When they suspect inheritance from an unknown predecessor, identity becomes complicated. National narratives prefer clarity. But cities are layered, always have been. Rome is built atop Rome, Istanbul atop Constantinople, atop Byzantium, London atop Roman Londinium. Archaeology constantly reveals earlier foundations beneath assumed beginnings. So why would it be shocking if certain 19th century cities incorporated pre-existing layers, whether from earlier in that century or before? The shock comes from scale. If multiple districts show buried first floors, altered street levels, hydrological shifts, simplified rebuilding phases, and staged-looking documentation focusing on finishing rather than foundation, then at minimum, we are looking at a more turbulent transition period than commonly discussed. And turbulence leaves scars. Scar tissue in architecture appears as bricked-up windows, misaligned additions, wooden extensions sitting awkwardly atop masonry curves, staircases added where doors once weren't. It appears as second floors repurposed as primary entrances. It appears as drainage systems that no longer function because original ground level changed. And when you walk these streets today, you can see it if you look closely. The question is not whether historians are malicious. The question is whether large-scale logistical inconsistencies deserve more investigation than they receive. 3 million bricks are not mystical, but 3 million bricks require coordination on a level that should leave massive industrial footprints, fuel records, quarry scars, transportation systems, workforce registries. Some of that exists, some doesn't match scale cleanly. When math and narrative feel slightly misaligned, curiosity is healthy. Because history isn't static, it evolves as evidence evolves. Maybe future excavation will clarify sediment layers. Maybe improved dating methods will refine timelines. Maybe archival discoveries will reveal missing industrial documentation. But until then, asking how exactly did this happen is not denial, it's engagement. And when you stand before a partially buried archway, when you trace the curve of a rounded brick corner hidden beneath a modest wooden facade, when you notice an exterior shutter designed more for environmental sealing than theft prevention, you feel that tension between story and stone. Stone is patient. It outlives regimes. It outlives textbooks. It waits for someone to notice the seams. And if there was a period of industrial contraction masked as uninterrupted expansion, that doesn't diminish the builders. It humanizes them. It shows how quickly complexity can rise and how quickly it can fracture. The 19th century may not be a tale of impossible construction. It may be a tale of interrupted momentum, a tale where some structures were completed under one set of conditions, then inherited under another, a tale where adaptation replaced ambition. But to see that, we have to stop looking only at commemorative plaques and start looking at ground levels, foundation lines, and brick geometry. Because the truth of a city is not written only in archives, it's written in elevation changes. And in the next part, we're going to confront the biggest question of all. If the math feels strained and the layers suggest disruption, what exactly are we standing on? So now we arrive at the question that makes people uncomfortable. If the math feels tight, if the logistics strain under scrutiny, if the architecture shows layering, burial, adaptation, then what exactly are we looking at? Are we staring at proof of a lost super-civilization? Or are we staring at something both simpler and more unsettling? Because here's the thing. History doesn't have to be fictional to be incomplete. Let's zoom out. Every major civilization has experienced interruption. Rome didn't vanish in a single day, but its infrastructure fractured. Aqueducts fell into disrepair, roads crumbled, engineering knowledge decentralized, monumental construction slowed. For centuries, Europeans lived among Roman ruins they could not replicate at the same scale. That's not conspiracy, that's documented regression. Now imagine a smaller-scale version of that pattern in the 19th century. A regional industrial boom, expanding brick production, ambitious civic architecture, skilled engineers. Then, economic crashes, supply chain failures, environmental events, political upheaval, war, revolution. Not fantasy, normal historical volatility. What happens? Complex systems break first. Brick manufacturing at industrial precision is not a village craft. It depends on consistent fuel supply, stable machinery, metal casting, replacement parts, trained labor, transportation networks, and capital investment. Disrupt any one of those long enough and output declines. Disrupt several at once and the ecosystem collapses. And when ecosystems collapse, people simplify. Wood becomes attractive because it removes dependencies. No kilns, no high-temperature control, no imported gears, no massive fuel stockpiles. Cut trees, shape logs, assemble. It's not inferior intelligence, it's adaptive efficiency. Now go back to those ornate brick facades with 30 or 40 unique profiles. Those aren't just buildings, they are expressions of surplus capacity. They represent a society confident in its stability. Decorative abundance only emerges when survival is not the immediate priority. When survival becomes priority, ornament fades. This isn't mysterious, it's human. So perhaps the strangest part of the story isn't that 3 million bricks existed. Perhaps it's that we're told everything flowed smoothly from ambition to completion without meaningful interruption. Because when you walk through districts where lower floors are buried, when you see bricked-up arches beneath current sidewalks, when you observe rounded masonry foundations supporting later wooden additions, you're not looking at fantasy, you're looking at transition. And transitions are messy. Let's address the psychological core of this. Why are people drawn to the idea that cities were discovered rather than built? Because inherited greatness is more dramatic than incremental growth. Because mystery is more cinematic than supply chain records. Because questioning official narratives feels rebellious and empowering. But here's the deeper truth. Even if some structures incorporated earlier foundations, even if environmental events altered street levels, even if industrial capacity contracted faster than textbooks emphasize, that doesn't require rewriting all of history. It requires refining it. There's a difference. We don't need secret empires hidden beneath clay to explain layered architecture. We need acknowledgement that rapid urban development in the 19th century occurred within fragile systems vulnerable to disruption. Take photography again. Those staged-looking construction images? They might not be evidence of deception. They might be ceremonial documentation, pride shots, promotional materials, public reassurance during unstable times. Governments and institutions have always curated optics. That doesn't automatically mean fabrication. It means narrative management. And narrative management intensifies after revolutions. When political power shifts, symbols shift. Decorative elements that once carried meaning become liabilities. Wreaths disappear. Plaques vanish. Architectural flourishes are reinterpreted as mere fashion rather than memorial. Over a generation, context evaporates. The next generation inherits buildings, but not explanations. And that's when speculation grows, because humans fill gaps with stories. Now let's return one final time to the number. 3 million bricks. If you break it down across multiple factories operating for years, it's not impossible. It's enormous, but not impossible, especially if output ramped during peak stability periods. But the moment you introduce production halts due to broken machinery, fuel shortages, transport delays, labor instability, the timeline stretches. So maybe the real inconsistency isn't the existence of the bricks. Maybe it's the compression of the timeline. Maybe construction took longer, paused more often, adapted more dramatically than simplified accounts suggest. Maybe some buildings were modified, expanded, restored on older cores rather than built entirely from raw ground in a single heroic push. And maybe we prefer cleaner origin stories because they're easier to teach. Here's what we can say with certainty. Cities are not single-layer events. They are geological narratives made of brick instead of sediment. Each era builds atop the previous one, sometimes respectfully, sometimes desperately. When you see a window below street level, you are not witnessing a glitch in reality. You are witnessing time. When you see a wooden structure perfectly tracing a curved masonry base, you are witnessing adaptation. When you notice exterior shutters that seem oddly designed, you are witnessing environmental response. When you struggle to reconcile industrial scale with fragile logistics, you are witnessing the complexity of pre-digital manufacturing. None of this diminishes the builders. If anything, it elevates them. Because building under unstable conditions is harder than building under ideal ones. Now let's confront the biggest fear behind questions like these. The fear isn't that historians are wrong. The fear is that if history contains gaps, then certainty becomes fragile. But uncertainty is not weakness, it's invitation. Invitation to examine quarry sites more closely. Invitation to analyze sediment layers beneath historic districts. Invitation to digitize and cross-reference industrial records with ecological data. Invitation to treat architecture as forensic evidence. The stones don't need mythology, they need measurement. And if measurement reveals smoother continuity than skeptics claim, that strengthens history. If measurement reveals more disruption than textbooks emphasize, that refines history. Either way, inquiry wins. Because here's the ultimate reality. No civilization is immune to loss of knowledge. No industrial system is immune to breakdown. No political regime preserves every truth intact. And no city emerges from a single moment. The 19th century was not primitive. It was powerful and fragile. 3 million bricks are not impossible, but 3 million bricks demand respect for the complexity required to create them. When we reduce that complexity to a romantic image of men with shovels and wooden scaffolding, we oversimplify. When we leap to hidden empires without exhausting physical explanations, we oversimplify again. The truth likely lives in the tension between those extremes. In the math, in the mud layers, in the engineering scars, in the missing gears that halted factories, in the wooden houses that borrowed curved foundations, in the streets that rose slowly or suddenly. History is not a courtroom verdict delivered once. It is an investigation that never closes. So the next time you stand in front of a 19th century brick giant and feel that quiet unease, don't rush to conspiracy. But don't silence the question either. Ask how. Ask how the fuel moved. Ask how the clay was shaped. Ask how the machinery was maintained. Ask how the ground level changed. Ask how political shifts influenced memory. Because when you start asking how, you move beyond myth and beyond blind acceptance. You enter analysis. And analysis is where real understanding begins. If this perspective challenged the way you look at historic architecture, stay curious. There are more numbers to run, more foundations to examine, more timelines to test. Subscribe, keep questioning, and never be afraid to calculate the story for yourself. Because sometimes the biggest mystery isn't hidden underground, it's hidden in plain sight, inside the math we forgot to check.